way. Now, by this time, you have been quite acquainted with the smart manufacturing issues. So, you know that the smart manufacturing is a data driven, collaborative, and integrated intelligent production system. So, this is the scenario of smart manufacturing. That means that different digital technologies are highly integrated and along with the being combined with the physical manufacturing. So the physical manufacturing has to be there whenever we talk about the production of some components. And then these physical manufacturing issues are combined, judiciously combined with the digital technologies so as to have very good efficiency in production efficiency, as well as it will be enable us to go for the predictive maintenance. The supply chain visibility is also possible, and that is very important because if we want to run a manufacturing system quite efficiently, then the supply chain visibility is very, very important for taking the customized action at any particular point of time. So this is very important issue. So naturally, the essence of digital technologies by this time, a lot of discussion have been there. So you have now become quite familiar with all these things. So I did not go into the details of that, except for the fact that uh, uh, if we do not really meet the different challenges which come across the implementation of smart manufacturing, then it's widespread adoption, right from the small industries to the larger organized sectors. That will be quite difficult a situation. So therefore, we have to meet the challenges. So we have to first of all understand what could be the possible challenges, and once we know these things, then it will be possible for us to do these things. Now, if we look at the drivers of smart manufacturing, we know that the need for the customization, need for flexibility, all these things that has led to something innovative in the manufacturing sector, and then that has ultimately invoked the smart manufacturing with the progress of with the advancement of digital technologies. So the combined digital technologies and the physical manufacturing system that ultimately entails the possibility of customization and as well as incorporates better flexibility in the operation. So that's the reason why the smart manufacturing people are hankering after this smart manufacturing. The other issues are that there is a tremendous competition. The transnational uh, manufacturing industries are there. So there is a tremendous global competition, and naturally, to win the race, we have to sustain the cost pressure. And moreover, any manufacturing system, it is very important at this particular point of time that once this century is branded as a century of environment. So therefore, it's very important that energy efficiency, uh, any process which we talk about has to be energy efficient and has to be eco-sustainable. The sustainability uh, goal is one of the primary set goal for any of the manufacturing systems or the practicing systems. So therefore, we also know that the sustainability and energy efficiency goals are the major drivers of the smart manufacturing. And then, as I already told you, that the rapid digitalization across the industries, that is another important issue that has come uh, to the industries, come in front of industries to take the due measure. So this is why the smart manufacturing people are talking about. So whenever we go for the smart manufacturing technological challenges, then we have to understand that the creation of a good technology infrastructure is itself is a technological challenge. That means what kind of technology configurations are to be there, what is for the specificity of a manufacturing item or manufacturing components. So therefore, it's not necessary that all the digital technologies available right at this moment in the digital arena will all be implemented there. So for a specific case of manufacturing system, of course, in today's scenario, long time back, I would say that's 25 years, since last 25 years or 30 years, that the concept has been changed. That because of the incorporation, need for the incorporation of the sustainability of an industry, then the rapid switch over the product diversification has been uh, has been a demand of situation, and naturally the infrastructurally it has to be conducive towards the diversification of product in respect of hardware, in respect of the software. So therefore these are the things which are quite important. That means if you ask one industry to switch over its production, then right from the beginning it has to have that kind of infrastructure which with minimum trouble can enable the manufacturers to switch over to a different product or a different kind of manufacturing. So therefore, this is important that the very judicious selection of the hardwares and very judicious selection of the equipment. So these have been the issues for the last 30 to 35 years. So therefore, that has already been recognized. Now, if I try to extrapolate that particular concept to the smart manufacturing sector, then we will have to understand that the similar logic is valid for the digital technologies to be implemented sorry, in a smart manufacturing system. So the challenge is that what the selectivity of the digital technology configurations. So that is another very important thing. And the most important part is that the integration of this digital technology with the existing legacy systems. This is most important thing, because unless it is there, then it cannot be retrofitted without, it cannot be a greenfield technology all the time. You cannot really start a new manufacturing sector. To start a new manufacturing sector, it's rather easier. It's an easier proposition. But to convert the existing manufacturing system to a smarter one, so there the question of the existing legacy, admissibility of the recognition of uh, existing legacy, so as to uh, uh, get it uh, possible, or I would say that get it retrofitted with the new generation digital technologies. So that is very important thing. So that's why we say that the integration of legacy system is another very big technological challenges. Then, whenever we will go for the digital technologies, there will be the question of the cyber security threats. So, the cyber security will be at question, that will be highly vulnerable. So, therefore, we have to think of that. So, that is another challenge, and that is another challenge. And then most of the time, as you have already understood, that the smart manufacturing essentially takes or collects data online data, right, during the course of manufacturing. So the huge data is to handle, so as to make the system adaptive, and for that the big data analytics is one very important aspect of the smart manufacturing system. So once that is there, then the complexity of big data and handling is an issue, whether storage, cleaning, real-time use, everything. That means you have to call the data from the storage system. So therefore, the cloud computing, edge computing, the combined cloud and edge computing business has come to picture, and everywhere, whenever it is just out of your the remote storage thing, remote storage system is there, then the question of the traffic jam, there's the question of the delay, the feedback delay, all those things will be automatically very important, because the manufacturing system is a continuous system. To the fraction of a second, some decision making is required. A fraction of a second, some operation has to be done. So if the entire operation, any subsequent operation is dependent upon the data, the previous data, then naturally the availability of previous data right at the time it is to get implemented, the process is to get implemented, is very, very important thing. So therefore, anything in between the transfer of data, any problem, that itself is a technological challenge. So naturally, that kind of synchronization of the data, uh, uh, the data collection and data storage, as well as the data feeding. So these are the issues. A proper synchronization has to be there, along with the physical manufacturing system, which is dictated by the digital technologies, the way it has to do. And then, so this is another big challenge. So that is a important challenge. And scaling solutions, that is another important. That is another challenge that normally in uh, a smaller scale we can conceive that how to implement the entire operation. But whenever we come to smart manufacturing, is essentially uh, meant for triggering the mass production, mass quality, and customized production. So that is what the smart manufacturing is for. Uh, and naturally, the scaling up of the pilot scale to a very small scale production, that is another important technological challenge. It is a common challenge that whenever we invoke a new technology, we try with the pilot scale, and then we try to go for the upscaling of the thing, and then this upscaling uh, is always a technological issue, and naturally that is another technological challenge. Then along with that, there will be the workforce challenge too. The workforce challenge means that we know very well that right at this moment, if I try to monitor any manufacturing system and the kind of digital technology we talk about for a smart manufacturing, state of the art smart manufacturing system, we find that there will be a lack of training in the digital technology. Maybe, suppose I want to have the skill of a worker in CNN, convolutional neural network. So it may not be there. He or she might be knowing something about the basic computational job. But when we talk about the AI/ML technique, or whenever we talk about the software driven IIoT, then these are the things where the familiarity and understandability is very, very important aspect. So therefore, that training has not yet taken off to the extent it is desired. So naturally, we say that it is a challenge, and also to be trained, there is a prerequisite. There is a prerequisite that this gentleman or gentle lady can be trained to the cust or can be his knowledge can be customized to the need of the system, manufacturing system. So for that, the prerequisite uh, knowledge has to be there, prerequisite training has to be there. So therefore, this is a challenge. So naturally, segregation of workforce, which are the training to be imparted to which kind of worker. So these are the important technology, important workforce challenge. It's not that everything can be imparted to everyone. So therefore, the people who are easily receptive or can be made to be receptive depending upon their background. So that is how one has to do this kind of thing. Otherwise, there will be truncation of huge manpower, and then naturally that will be a catastrophe in the sociological aspect, societal aspect. So therefore, we cannot really do that kind of thing. That's the reason why the training, whenever we talk about the lack of training in digital technology, we really mean that the training is a person specific, the customized training it has to be there, and each and every person's training is dependent upon his receptive capacity, which again is dependent upon his prior knowledge, prior education, prior training, all those things. So we have to screen out, we have to see, and we have to make best use of the highest possible available skill from any particular worker. So that is a very serious challenge. Then, then as a corollary to that, you can always say that there will always be a skill gap in artificial intelligence, robotics, and IIoT. I have already refer to that. Then there could be the resistance. There could be the resistance from within the workforce due to the fear of job loss. Because whenever we are talking about the so-called high-end digital technology, what we call high-end digital technology is no longer high-end at some point of time when people will be familiar in that. So the basic issue is that it's a qualitative, it's a relative issue. It's a relative issue and a little bit of subjective in the sense that what is uh, the advanced or what is the state of the art technology unreachable to the people per se right at this moment will be ultimately usable to the people at a later time. And naturally, that time they will be quite familiar with that. So, non familiarity with the technology, we are talking about the smart manufacturing system. So, therefore, again, I say that if there is a group of people who are lagging behind the advancement of technology, so that is a problem which can be noticed globally. So therefore, it is a very important challenge. So long as we are not doing this kind of thing, there will be the psychological makeup, the inherent psychological, genetics-driven psychological factors that will be coming to play, and they will be having the fear to lose their jobs because they feel fish out of water that we do not know this kind of technology. So therefore, maybe implementation of this technology will ultimately make us lose our jobs. So therefore, there will be a resistance towards implementation of that particular thing. So that's a nature that's historically proved. So therefore, that kind of resistance has to be overcome by the people who are in who are the advocates of the smart manufacturing. So the advocacy has to be uh, supported, duly supported by taking the measures to eradicate the resistance towards the change of the technological aspect, the technological scenario. So then, uh, even if that is there, suppose everything is overcome, then the challenge is not overcome. The challenge is not end. That's not ended. Why? Because it's not that whatever digital technology we are talking about today, tomorrow it will be the half lives of all these technologies are very, very limited. So therefore, we know that the half lives are gradually diminishing. I mean, it's around say 6 months or so. Or say even 6 months is too long a time. So therefore, the you can find that after 6 months or 1 year, the technology will be obsolete. So the new generation digital technology will take its place. So therefore, the continuous test, learning and upscaling in this particular age of information age or information in this digital age, so automatically the learning has to be continuous learning. Every day newness is coming across us. So therefore we have to learn, we have to upskill ourselves, otherwise we don't survive. So this is a very, very important thing. Why does this pressure come? This pressure comes from the intelligentsia. That the intelligentsia, they are harping for more and more discovery, more and more inventions, and naturally newer things are coming to picture, and newer things are giving more certainty, incorporating more certainty into the system, incorporating better uh, reproducibility into the system, and quite obviously that becomes aggressively accepted by the people, by the user industries. So therefore, there will be a continuous shift of the technologies, and naturally there has to be a continuous learning or upscaling, upscaling of our own skill. So these are the another important challenges that human machine collaboration. In many cases, human machine collaboration, the cobots, when that is there, the robot and human, when that collaboration has to be there. Lot many areas are there where it is to be done. Now, when that is there, then that kind of training of robots is so important, and training of the people is also important. I'll show you one example where something can be conceived. And then there are other challenges, the financial and investment challenges. Now, right at this moment, the people are not very much aware of the implication, the intricacies of the smart manufacturing. Oh, it is a very broad way of saying that the digital technologies and all those things. But the investment is quite high. The capital investment for making the entire system a smart system is quite high. So therefore, the immediately not knowing the risk to reward ratio, having had no knowledge about the risk to reward ratio, the management of any manufacturing system, they will be hesitated. They will be hesitating to go for a very big scale investment because it's not the return on investment is uncertain. Specifically, the people who are the front runner in that, who are the front runner in that. So they have to face the music. So therefore, there is an uncertainty in the return on investment. So naturally, whether that big capital investment will be a judicious decision or not. So that kind of hesitation will delay the process, and delay by default will in, will invite more of capital investment because the technology will be changing. So therefore, this kind of vicious cycle is there to be faced by the management or the top management or decision makers of a management sector of a manufacturing sector. And more importantly, whenever we do such kind of things, whenever we take such kind of risky venture, then there are the availability of venture capitalists, the venture investment. So that uncertainty in venture investment is another important challenge because the venture capitalists, they do not know that what is again the benefit which I can accrue out of this venture investment. So there is a definite risk, certainty, uncertainty factor is there. But still then, it's just like the way the insurance company, they are working. On the law of probability, on the law of probability, on the probability of success. So in most of the cases, the venture investment is a successful uh, issue. Otherwise, that concept would not have survived by this time. But in this particular sector, when the sectorial development is in process and that is in its infancy, then in that particular case, the venture investment itself is an uncertain issue. So therefore, that is another important financial challenge that if I do not have the venture capital, then how do I do this kind of thing out of my pocket? I have to invest these things. But again, I am not aware of what is the return on investment. So therefore, this is one important challenge, but somehow or other you have to do it, noting that the counter pressure is that if I do not do it today, tomorrow the same problem will come to me with a higher requirement for investment. So therefore, this is the thing. And more importantly, that the small and medium enterprises, they are also uh, deficient in uh, the resources. That means they have got the limited resources. So they have the problem of the resource crunch. So therefore, whether they will also be possible to be made aligned to the concept of smart manufacturing is a very important financial issue. I mean, not the technological issue here, not the mental eagerness. It's not the issue. Issue is that the ability, issue is the capacity of investment. So that is another important thing. And then the economic volatility, that is another important. That is a global economy, if one looks at, then one can find that a lot of uncertainties are there, lot of recesses globally the different countries are facing. So naturally, and the global trades, they are taking a very, very complicated shape. So the international political scenario quite often changes the economic situations, and then the trades amongst the different nations. They are getting so much of change. You can find that every day there is some kind of change. So that's the reason why you will see that tremendous inflation can be faced by some countries. So there can be even we do not know what is going to happen. The I mean, within the last, say, 50, 25, or 50 years, the number of diseases we notice in a number of countries. So naturally, ultimately, they have managed it with some kind of economic strategy. But the issue is that this is a volatile situation. With this volatile situation, the decision making quite obviously becomes very difficult as well as challenging. So this is the major issue. So naturally, whether or not it is prudent to go for investment so as to have the smart manufacturing, and the consequences or consequential benefit of smart manufacturing is not yet tested by people. So in the strategic sector, yes, it is possible, doable, because a lot of investment uh, are available. But in the day-to-day manufacturing sectors, like the consumer items, so there the issues are still not yet tested. So therefore, there will be some kind of confusion, some kind of thing. But ultimately, this is a law of nature. It has happened previously also when any particular industrial level revolution has witnessed, right, uh, such kind of inertial problem. So that similar problem, it is some kind of inertial problem which ought to be overcome, and some days will be there when the entire sectors, manufacturing sectors, will be smart manufacturing sectors. As I said, that this has got the impact on the organizational management issues also. So these are the challenges also, that the sensitization of decision makers, whatever we have discussed till now. Now the issue is that we have uh, tried to bring out the confusions, the dilemmas which can be there in the decision makers. But if the sensitization is proper, the sensitization is proper. That is, the decision makers are sensitized properly. That these are the kind of things which ought to be there, and this is the if the technological advantage is there, if the final advantage is such as such. So if that kind of sensitization is there, then that will be possible. It may be possible that they will be more keen towards taking a decision in favor of going for smart manufacturing and industry 4.0. So the major issue is another issue is that the digital strategy is not very clear, neither to any local company or to a country or as such international fora. So there is nothing. The other areas they have got the clear cut strategy, clear cut standardization process. Here that is not there. And then when this kind of smart manufacturing is there, by this time you have been used to what manufacturing sector, smart manufacturing sector is. So once you know that, you find that huge data flow across the departments will be a need for any manufacturing system. So therefore, the departmental silos, that will also sometimes hinder the possessiveness and the interpersonal conflicts. So, and I mean, that is again evolutionary uh, problem. So therefore, the equanimity is always there. So therefore, the departmental silos may hinder the data flow unless the management is very, very transparent, very, very clear. Whatever, whichever is there, but always you see that some feeder group, uh, feeder group and the fed group, they have some kind of barrier in between them. So this kind of barrier has to overcome. So this is this kind of some kind of barrier. It's like a quantum barrier. So it will see you will see that this kind of barrier is there. So the data flow will always be hindered due to that. We are always to be hindered due to that. So it's again that is a basically that is quite akin to a physical science. So naturally, this is nothing away from that concept. So therefore, I always foresee I always see it like that. So naturally, that's a law of nature. So it will happen. Now the thing is that how the driving system or the drivers of the manufacturing system or the decision makers, how they are organizing the entire thing, that will depend upon whether these resistances can be minimized or not. So that is another issue which has to be overcome. I don't say that this is not possible to be overcome, but I simply say that this is an issue. This is an issue people have to take in consideration, people have to face it, people have to uh, live with it. Then the resistance to the organizational restructuring. Whenever you will have a smart manufacturing system, the transition from one particular system to the another system, there will always some barrier. Whichever way you think, whichever way you think, going from one particular uh, place to another place is an energy expensive process. Is an energy expensive process. So whenever that is there, the organizational restructuring is an energy expensive, or energy expensive means that you can energy and finance, you can make them equivalent, whatever you do. But basically there will be the restructuring, uh, uh, resistance will always be there. You cannot really, you can think of any of the things that even your domestic issues, you can think that from a cottage, if you want to organize your entire system to equivalent to a very high quality residential building, then you can find that there are a lot of challenges, restructuring challenges. There are a lot of resistances. So these things will always be there for any kind of industries. The other important challenge for the management issues that the data ownership, that is also not very clear. Whose data is that? Data ownership is another important thing, and the governance of the entire system, that the data owners. Now sometimes the data become a common issue, that open source data. So if you try to grab that thing, there will be a problem. So naturally, that kind of understanding has to be there globally, and naturally, sectorially, you can have one thing. The problem of global problem can be reduced back to an in-country problem, and that can ultimately be in one organizational problem. So this is the thing. Then in the micro scale, that will be the issue. So therefore, this data ownership and governance is another important issue. Most important point as it comes to my mind is that the strategic management issue. The strategic management issue in digital technology. Now, unless the strategic management is very strong in an organization, so far as the digital technology implementation is concerned, it will be a very, very critical issue, as, which must have to be surmounted. So the way you will manage the digital technology is another important aspect. Then the other challenges are also there. A little bit I had already explained, but important point is that at some point of time, that just like ISO 9000, there is a standard, global standard. But in this particular digital technology, the global benchmark is non-existent. So therefore, at some point of time, people may ask that this is not allowed. People may ask that by this you have done harm to me. So all these things are possible right at this moment. So because the global benchmark is not available, so that has to be there. In some days, definitely it will be there. And then no universal standard across the IoT devices are there. So the no standard is there. So anything is now available anywhere. So therefore, if standardization process is not there, the decision it impacts the decision making. It impacts the decision making. It impacts the financial decision making. The people who are facing these challenges in their day-to-day professional lives, they can understand what I mean by this. That if the IoT devices do not have any universal standards, then the implementation of the IoT technology will be difficult. organizational difficulty because a lot of ifs and buts will come to picture. Compliance with the strict industry regulation. That is another important thing. That there are already laid down regulations, internationally acceptable regulations for the industrial regulations. And naturally, whether the new generation digital technology has to be is compatible with the industrial rules or regulations. That is another important aspect. That kind of compliance has to be there. Then the data privacy or cyber security laws. I mean, very vaguely describe cyber crimes and cyber security aspects are there, but it is not yet certain that how do you check the data privacy or the cyber security. What is the international standard? What is the global standard? What is the in-country standard? That is also very specific cases. Some cyber security laws are there. But it's again, sometimes it conflicts with the uh, what should I say, that personal freedom. So naturally, many cases it happens. Many cases it happens. Specifically, the social media are facing these things. That what is to be called as a cyber security is again something goes against the personal freedom. So that's the thing. Quite often you can find that a lot of legal issues are coming up with this social media because of this conflict between the cyber security and your personal freedom. Freedom to discover, freedom to understand. If you have a freedom to discover something, to do a good job, then you can also have the freedom to find a technology or find a software, find a malware to give a check to that. So therefore, these kind of conflicts are also there. So there has to be some definite regulations. There has to be some definite rules so that it has to be there. That what is to be done and what is not to be done. So that clear-cut borderline is not there. So that's the reason why the situation is becoming more and more complicated and it's more and more challenging. Cross-border trade restriction on data sharing that is also still existing. Now nobody can really share the data that because of the other issues, because of the other security issues. Data sharing, so far as who will say, it is just like the issue of the technological empowerment in the atomic energy or something like that, the atomic power. So therefore, uh, although a lot of words are there, but the countries they are acquiring the atomic power, uh, and then uh, the thing is similar to that. It's similar to that. The cross-border trade restriction is there for the data sharing. That's all right. But sometimes some data or the cause of the global technological advancement, sometimes the data sharing should be required. So who is there to do all these things settle that okay, these are the data area of data where we can share globally. So that is that kind of rules, that kind of uh, protocol is not yet existing. Insurance policy against the unforeseen massacre. That is another important thing. There is no insurance. I mean, if you find that their house you can insure, force majeure, if that causes any damage, then the insurance company can take care of it. Personal insurance is there. So personal limb insurance is there. Personal pos- possessions insurance are there. So many things are there. But what is not there is that the data repository damage, insurance against damage. Suppose your one cloud has crashed. So it's just like a bank failure. It's just like a bank failure. So if it crashed, then the company gets darkened. The smart manufacturing sector gets darkened. Then there is no insurance coverage. So that's the reason. That is another important aspect. That is what it came to my mind. Then the social concerns and sustainability. These are the other important challenges. So this is another important challenge that normally till date you might be knowing, many of you might be knowing, people, specifically the people who are working in the computer hardware industries, they are quite aware of it, that the energy consumption, a minimization of energy usage for a particular computational job is one of the major research areas. You will see that your computer gets heated. Now that is because it is consuming more energy and it will create damage to the computer hardware or the processing unit. So therefore, it is important that the energy consumption of the digital infrastructure that has to be minimized, because whenever this energy is there, then there is a question of the ecological sustainability. How? Because if and so long as the entire energy supply is not from the non-conventional or renewable sources, then any advancement in technology will automatically be equivalent to the greater higher emission of carbon dioxide, the greenhouse gas, and quite obviously that goes against the your the protocol of carbon uh, usage to naturally carbon equivalent. So therefore, uh, it is important that energy consumption has to be minimum. Then more of use of the digital technology. You might be knowing that e-waste management is a very big deal nowadays. People have now become very cautious and they know it. E-waste management that itself, now it itself has emerged as a sector in waste management sector. So naturally, more of e-waste will be generated from the sensors and the devices. More usage of the digital technologies will ultimately give rise to more of e-waste. So the e-waste recycling management means that unless we can make the entire society recyclable, then we are not done. So therefore, the question is that the recycling uh, is a major issue. If we can use the if we can implement, if we can make the system, the society recyclable, then quite obviously we will be able to do something. We'll be able to do something by virtue of which we can manage this system. So this is one important thing. This is one important thing. And the other important issue is that job displacement fears due to automation. So this I have already told a little bit, but basically this is again this concerns the sustainability of automated industry. But we are talking about not the automated industries. We are talking about the autonomous industries. So autonomous industries, they will be concerned more of the e-waste generation and then the ethical concerns in the AI decision making. So this is another important thing, that we do not have any borderline or uh, ethical frame of framework, that what is the definition of ethics so far as the use of the AI based decision making system is not well described, it's not well spelled. So naturally, this is another important point, that AI based decision making can lead to something which basically in contravention with the social ethics. So therefore, this aspect is has to be there for the nanotechnology, the ethical concerns, the ethics in the nanotechnology, that has been addressed early. But what has not been addressed, the AI based decision making. AI based decision making, the ethical issues which can come across, that is not yet taken up. So naturally, these concerns uh, are to be addressed. Then, uh, we if we make a system non-sustainable. It is all right. Everyone knows that when in the last century, which was branded as a century of economy, unproliferated use of the resources of Mother Earth, that ultimately led to the catastrophic situation which we are facing in this century, which is now branded as a century of environment. But what has happened? That was because of the maximizing of profit. Maximization of profit was ultimately tampering the wisdom of nature. So the sustainability was at stake. Now, uh, today, that kind of balance has to be there. That whenever we talk about several kind of things, as for example, the genetic commerce. So the genetic commerce there, the genetic pollution is there. The who is there to create that balance, to create that balance between the profitability and sustainability. So naturally, that is another important aspect. There has to be some global agreement. If that is not there, in-country agreement is first of all it is required, or in society agreement is required, or in organizational sector is important. So these are the things which are missing right at this moment. So there has to have a definite balance between the profit and the sustainability. So unless that is there, then the other aspects are lost. The social concerns we are defeated in that. Now coming back to the safety concerns, we have got the different safety concerns. That one is the human machine collaboration risk. So this is the important thing, that suppose you have to feed one uh, thing to a robot. So robotic hands that picks up. Now if the synchronization is not proper, the put the you put it, and then the speed with which the robot is picking it up, if that is not, uh, the robot can catch hold of your hand, and it will not, it does not know how to release, when to release. It simply knows that it has to be put, and it has to be released only at that particular point where the job has to be released. So therefore, this human machine collaboration risk is always there. It can lead to accident. Cyber security threats, I told you that the entire IIoT can be damaged, that can be made to a scrap. So if that cyber security threat or that safety is not ensured, then the equipment malfunction or breakdown, predictive maintenance is there, is possible. But the point is that if suppose accidentals are recognized by the modern day technology, modern day physics, modern day technology. So if there is any accidental malfunctioning or breakdown of equipment, then how will that digital technology respond to that kind of thing? How can I really make a partition between the digital technology and the basic conventional physical equipment malfunctioning? So that is another important thing, that who is there, just like we have to have in an electrical system, just like the circuit breaker kind of thing has to be there. That if the equipment, I mean, that kind of safety system is required. That if the equipment malfunctions, then the entire digital technology will cease to operate along with this machine. So some kind of braking system, of interfacial braking system has to be there, such that at least the digital technological uh, hardware that can be saved. So this is a great safety issue, and it is a technological issue also. So you have to devise that kind of technology. So that kind of interface software has to be created such that any malfunctioning will signal to this interface software, and this interface software will ultimately disconnect the entire thing. Then again, who is there to set it all right? Again, will we come back to the conventional means which has been there, that the inducting people to set the equipment all right, or we will make use of digital technology to maintain or to make this thing right? So that is another important question that depends upon the equipment's actual equipment wise. And then the hazardous material handling. Hazardous material handling, this is a safety issue, no doubt, but implementation of robots with proper uh, sensors, that is another important technological area that people are talking about to handle this hazardous material so that this safety can be uh, there. But again, the question is that the robots, the material of the robots, how does it interact with the hazardous material? If suppose I buy hazardous, I say it's highly corrosive to the body of the robot, it corrodes, then quite obviously that is not one which is suitable to handle that hazardous material. So therefore, these are the issues, the material specific issues, and sometimes in accordance with that, the technology has to be chosen. But nevertheless, it is a safety issue, the hazardous material handling. Data privacy and compliance, I've already told you what is the problem, what are the safety issues there, and then if the data privacy is not maintained, if that kind of thing is compliance, is another important safety issue. The compliance is not proper, then the entire system can ultimately crash down and can lead to a catastrophic situation. You see that whatever you do in your smart manufacturing system, whatever you do, ultimately that has to have the compliance with all these international, already existing international safety standards. ISO 45001, that is the occupational health and safety. ISO 12100, that is the machinery safety. Then the IEC 61508, functional safety of electrical and electronic systems. Then NIST cybersecurity framework, that is another thing. Then ANSI ISA 95, integration of enterprise and control systems. So these are the international safety standards. Nobody can get rid of it. So whenever we are talking about a smart uh, manufacturing system within Industry 4.0, this kind of thing has to be embedded along with your security systems, your safety systems has to have a very good compatibility, very good compliance with any of these. So this is the another important clue I would say to devise the safety standards for a smart manufacturing system. Now, in the smart manufacturing, smart factories, the digital safety is a communication protocols. You have to have a secured communication protocols. So this is what I try to hint that whenever there will be a communication in between uh, any two IoT device or any two I mean the data storage and data users. So there everyday communication protocol has to be made perfect and that has to be made secure. Then the real-time monitoring of IoT devices. IoT devices can also be trained. So therefore, there has to be some supervising device will has to be there that which will monitor the IoT device. That means some kind of feedback system can be there, some kind of feedback monitoring system can be there. So this is the other thing. And then this is another important aspect, the role-based access control. That suppose one particular IoT device has got a particular specific role, and only and I have been allotted with that, so I will be having the access. Partly this is being done for most of the cases, even in banks, the people are doing this kind of thing. An individual man-machine coordination, there they are doing it, but it has to be much more extensively done. And since it is an autonomous industry, so in the autonomous industry, the man has to be replaced by machine. So therefore, the one machine can access to the output of another machine only if it is required to do so. So therefore, this is another important aspect. You cannot capture data from anywhere you like. So that kind of shielding has to be there. Then the predictive maintenance for risk reduction. That is possible. I have told you that this is another important attribute of smart manufacturing system. So it will be there. And then the AI driven anomaly detection. So this is the important thing. So what we have to do is that the workers' safety and training, collaborative robot cobots, safety guidelines, wearable devices, health monitoring, virtual reality safety training, regular emergency drills. These are the things which are to be practiced, compliance with ergonomic standards. So this is another very important thing, that ergonomic standard, that whenever you are going for this digital technology, ergonomy is very, very important, because the human uh, or anything, uh, whoever the are basically monitoring these things, the ergonomics is also very important for the longevity of that particular person. So these are the important areas where the training is required, the safety guidelines are required, and uh, also the good monitoring is required. Now, if you look at the things, you will see that in the automotive industry, covert safety zones are there, uh, where a lot of safe safety practices are there. Then the electronic manufacturing system, the predictive maintenance adoption is there. Then pharmaceuticals, there you will have the strict compliance with ISO standards. Then cyber security protocols must be followed to reduce the downtime incidents. So therefore, we can say that smart manufacturing, for a smart manufacturing, the safety standards are vital for making the smart manufacturing a sustainable proposition. Then we have to have a balance between the productivity, safety, and cyber security. This is a very important point, that the balance between the productivity, you cannot increase the productivity at the cost of safety or cyber security. You cannot go on increasing the safety at the cost of productivity and cyber security. So there has to be a judicious balance among these three components. Ongoing training and compliance ensure resilience, so the system resilience can be improved by that. Then the smart factories of the future must be safe, secure, and reliable. Last. So what we summarize is that smart manufacturing, we have to admit that it is the future of industry, but there are challenges to survive. The solutions will be the cyber security has to be made intact. Incentives have to be given, upscaling of the workforce, then the standardization, global standardization. And then the other important aspect is that we have to encourage sustainable and responsible adoption. That means that culture has to be imbibed, and it is a need, as it was always, a collaboration, a real life collaboration between industry, academia, and government. That is the key to the success of transition from the conventional manufacturing to the smart manufacturing. Thank you all for your hearing.
Thank you very much, sir. Now, participants, if you have any query, please put into the chat box. Uh, Sir is happy to answer. Sir, we have one query. What challenges do SMEs typically face when trying to implement and maintain international standards, and how can these challenges be effectively addressed?
What is that? What challenges do SMEs typically face when trying to implement and maintain international standards, and how can these challenges be effectively addressed? Now, Mr. Arora, if you have made these challenges for the conventional manufacturing, then I would say that the quality improvement conforming to the international standards is a solution. But if you are meaning that smart manufacturing system, then the issue is that what you have to do is that you have to digitize your, you have to implement the digital technology for your, I mean, it is basically dependent upon the in a small and medium enterprise. This is a difficult proposition right at this moment because of the resource crunch. But what you can do is that there are certain solutions which are a little bit, uh, I would say that easier solutions, easily available with less investment. So naturally these kind of thing, uh, I mean, suppose the robots you can use for any repetitive work for the mass production. You can at least automate the industry. That is not a very costlier deal to make it absolutely autonomous. The way I said that those challenges are to be faced. Now, naturally, for the challenges, they are unique. They are unique and they are generic. That means whatever challenge is there for SME, the same challenge is also there for the organized sector. Organized sector can effectively meet it, but the SMEs cannot meet it so easily because of the decision making dilemma. So that's why I'm saying that these challenges, they are generic. And then if you try to implement the smart manufacturing, then sectorially I would suggest that sectorially you do that kind of thing in compliance with the international standards which are already laid down. I had already given you that kind of thing, and you can consult with those depending upon its products, and then these challenges can be addressed. But the issue is that uh, unless you the SMEs, I mean, it is a specific to the product, to the manufacturing business of that particular SME, which will ultimately tell us that what is to be done. Now, the the first and foremost thing is that whenever you will be using the IoT, it is a very easy, I mean, easily doable proposition, because you have been seeing that your television, your lightings in domestic, it is they all are making use of this IoT concept. So therefore, it is easier. So to run a machine, to make it off, to make it on through a mobile from the distant operation, that is also well known. So you can do that. Now the thing is that the process efficacy, the decision making AIML, that you can also interface it with the decision making system. That is not a very costly deal. But so long as you are trying to do it for the entire manufacturing or sector, then that will be a costlier one. But what is suggested right at this moment, that you can, one or two areas you can really make use of your digital technology, and you can ultimately address it. But you are right that the much more challenges will be faced in case of SMEs.
Okay. Okay, once again, thank you very much, sir, for delivering such an excellent lecture on the challenges in smart manufacturing, thoughtfully addressing the key aspects as sustainability and security. We are confident that the insights shared today will greatly enhance the participant understanding of this important subject and encourage them to engage further with the emerging trends and solutions. We sincerely appreciate your valuable time and contribution. Thank you very much, sir. Participants, next session will be delivered by Dr. Jinup Ekrekal Narayana from UK. So the session will start within few minutes. So please stay on this platform. Thank you very much. Hello, good morning, sir.
Good morning.
Hello, Jinoob, sir.
Good morning. Good morning. How are you?
Mute again. Are you? Sir?
Good morning.
Good morning, sir. Please share your screen so we can.
Can you hear me? Can you hear me? Hello?
Hello, sir. I'm audible?
Can you hear me? Am I audible?
Yes, sir.
Yeah, thanks. Can you see my screen?
Yes, sir. Your screen is visible.
Good, I think.
वैसे तो मैं कैब को आपको 4:30 हो गया स्टार्ट
Can see my screen, right?
Yes, sir.
Yeah. Thank you so much.
Okay, sir. So, dear participants, Dr. Jinoop Erekal Narayanan is the fellow of Institute of Materials, Mineral and Mining, chartered engineer and senior lecturer in mechanical engineering at School of Computing, Engineering and Digital Technology, Teesside University, UK. Prior to this role, Sir held position at the Welding and Additive Manufacturing Center at Canfield University and the Laser Additive Manufacturing Laboratory at Raja Ramanna Center for Advanced Technology, RRCAT, Indore. He leads the Laboratory for Advanced Materials and Manufacturing Processes at Teesside University. His research interests span metal additive manufacturing, surface engineering, process structural property, correlations, and development of advanced manufacturing for net zero applications. He has authored around 100 research articles in which, uh, including peer-reviewed journal articles, book chapters, and conference papers at both national and international levels. Notably, he has authored at the first comprehensive textbook on advanced additive manufacturing in India. In addition to his research, Sir has served as an editor and reviewer for several esteemed international journals, funding bodies, and conferences. He is an editorial board member of Research in Material Science, Frontiers in Manufacturing, and guest editor for several research special issues. He is actively involved in collaborative projects on metal additive manufacturing with international universities, research labs, and industries. He is currently leading and collaboration on projects funded by Royal Society, Royal Academy of Engineering, Innovative UK, Department for Science, Innovation and Technology. Sir, this is the brief introduction about the sir. Sir, over to you, please.
Yeah. Thank you so much.
Please share screen, sir.
Yeah.
Please share your slide, sir.
Yeah.
Yeah. Thank you, sir.
So, thank you. Good morning, everyone. Thank you so much for the invitation and thank you so much for the introduction. So, myself, Dr. Chinu Barakal Narayanan. I'm a senior lecturer in mechanical engineering at Teesside University in the UK. And I'm also an adjunct professor at Satyabama University in Tamil Nadu.